last type is a scalene triangle, no sides, no angles, congruent.
Okay.
Is that okay?
Yeah. Yeah.
All right. Then the next thing is, and these typically are sides or angles, but a lot of times people look at them just as sides first. The next thing here is a right triangle. Right triangle has one 90-degree angle, which is indicated by that little square there.
Okay.
An obtuse triangle is an angle greater than 90.
Okay.
An acute triangle is an angle less than 90, but it's actually all angles. Wait, you're right, that all angles, not an angle, all angles.
Okay.
All angles less than 90. Okay. And from here, there are combinations of words that work.
All right.
All right. And that's for you to determine whether it's possible or not. I would recommend writing all this down.
Yeah, I
Or
have been.
good. And because I want to kind of you do some true false with this with you.
Mm.
Basically, like go through something here, and I'll give you an example here. Is a right isosceles triangle possible? Possible or not possible?
Um.
That is the question.
Would it? Yeah, it would be possible.
Okay,
Or
so what I want to do here,
no, it wouldn't be. Sorry, because it has to be two sides.
I'll look here. I'm looking at our notes from last time because I don't remember if we did any of these. We did not. Okay, that's good because I found some really good ones. So let's start with a right triangle. Here's a right triangle. So that part, check. Okay. What does isosceles mean?
Two sides are congruent and two angles.
So what if those two sides are congruent? Is that possible?
Yes.
It is. Sure is. Okay, so this one is possible. Okay.
All
How
right.
about an obtuse equilateral triangle? Obtuse equilateral triangle. This is where it gets tough. You have to sort of start with one word or the other and then make a decision about what it could or could not be, what it could be or could not be.
Okay.
So what do you think?
Um.
Which one do you want to start with? An obtuse triangle or an equilateral triangle?
Obtuse.
Okay.
Excuse me, sir. I'm Remy's dad,
Yes.
and I'm trying to learn this with him so I can, help reinforce what you're teaching him.
Sure. Sure.
I hope you don't mind.
Yeah, no, no. No, you're welcome to join on the Zoom if that's,
Yeah,
part of
I
this.
just
Yeah.
think Remy needs it. Like I feel like right now he's not knowing even what the question is.
Okay.
What's he asking you?
Because you were talking to me, so I
Oh,
couldn't hear what he was saying.
okay. So an obtuse triangle. The question is, can it be a right? Can it be an isosceles? Is that the question?
No, the question, well, so with Remy, what I really am trying to do here, I'm glad you're in the background, is I want him to either tell me what an equilateral triangle is or an obtuse triangle to start. And he seemed to struggle to know which one to choose. It really doesn't matter. You just pick like, all right, obtuse, equilateral. And then I want him to tell me, well, what does it mean for it to be an obtuse triangle? And so the question is this possible? Is this even possible? Because these are the types of questions that they tend to ask in that part of the course. It's all pure definitions, pure like, is this right or wrong?
Yes.
And so I want him to be able to tell me what an obtuse triangle is and an equilateral triangle is without like any hesitation. And it doesn't matter which one. And then we'll go see if the other one is even possible from there. So like in the previous problem, he started with a right triangle. I drew a right triangle. And I asked him, well, what does it mean for it to be isosceles? He said, well, two sides are congruent. I said, well, could these two sides be congruent? He said, sure. So yeah, this is possible.
Right.
For this one, though, he's got to decide. And by the way, this one is not possible. Maybe that is where there's some uncertainty on his part. I'm not sure. Uh, but that's the goal here.
So an
Um,
obtuse triangle can't be equilateral. It could be a greater than 90-degree angle and two
Right.
legs.
So here's what I was hoping he would tell me, and he started doing that is saying,
Right.
okay, an obtuse triangle has an angle more than 90 degrees. So let's just pick 100 degrees right there. So what does that mean what does the equilateral triangle mean? Well, it means that all sides are congruent. And I would ask him, well, do these sides look congruent to you? Like, do they visually appear to be the same length? If you got a ruler out, are they the same length? And I hope he would say, no, they are not.
Does it also mean equilateral that all three angles need to be the same?
Yes, yes.
So if an
So
angle,
that's where we might start with, okay, let's start with an equilateral triangle.
right.
All three sides are the same. All three angles are the same. Now, in class, hopefully they covered somewhere that the sum of the angles is 180, which means that if all three are the same, and so right after Remy to jump in, tell me what is each angle if all three are add up to 180? What does that mean for each angle measure?
It would be 60 each angle.
60, right? And so that's where I would say, okay, we've checked the box on equilateral. Can it be obtuse? Are any of these satisfying the condition for obtuse?
No.
No. So this is not possible. So no matter which way you go, you can't get there.
Yeah.
And I'm sorry, I don't remember your dad's name. I'm sure he's
I'm
told me
Jesse.
once.
What was your name?
I'm Matthew. Sorry, one more time.
Matthew. I'm Jesse.
Jesse. Okay. So yeah, I mean, please jump in or if you have questions or concerns, I mean, that's what this time is for, is to figure out how to best help your son.
Absolutely. Absolutely.
My concern with Remy has always just been, is he able to recall the information that we're working through later on? Like, he always seems to do a good job in the lesson of telling me like the things that I want to hear to confirm that he knows. It's just I don't know what happens outside of that.
Yeah,
And
not to upset Remy, but he has a habit of trying to speed through things and not fully understand them. And he pays the price. And we're trying to start this year off right. And I'm
yes,
trying to reinforce the beginning process and getting all the vocabulary and these basics down. So as he goes through the year, it'll make more sense. And but yeah, he has a habit of breezing through it before he fully understands it, and that's why I'm here. So if I understand it, I can kind of quiz him on it and make sure he has a deeper understanding of it after the fact.
so here's another one. So is this and it's an acute isosceles triangle, is this possible or not possible? All right, and let you guys
So
I'll
an
let
acute
you
means that all angles are less than 90.
okay. Yep. That's what I want Remy to be able to tell me right now. Is like, what does that mean if it's acute? All the angles are less than 90, and either start with that triangle or start with an isosceles triangle and see if you can make the other one true.
Go
And
ahead,
it
Remy.
doesn't matter which way you go, you just have to pick a direction and say, okay, I'm gonna
Okay, so
start
can
with
we just
one.
do isosceles then?
Okay. So on your paper there, draw an isosceles triangle for me.
Okay.
Doesn't matter what you draw. There's a couple of options here.
Yeah, it was just a normal triangle. All
Okay, so
sides.
did you put this at the top or at the bottom? So does it look like this, or does it look like more like this?
I did it at the top.
So Remy
Okay,
drew
so the one
an
on,
equilateral triangle. Is it an equilateral can also be an isosceles or an iso?
Well, I did it. No, sorry.
Well, that's
I
okay.
did it with two lines that are the same, and then the bottom one isn't.
Okay.
so there's two possibilities here. One is where this angle right here, we'll get to the whole like isosceles and equilateral, is this could be an acute angle and this could be an obtuse angle.
Okay.
Okay. Um, and it depends. It depends on how you draw this. So the two sides here are congruent, and that means these two angles are congruent down here, but it doesn't tell you anything about this third angle. Because
Yeah.
let's just say these two base angles were like 65 and 65. Okay. That third angle, X, what would that value be? And it's X plus 65 plus 65 equals 180. Could you solve that for me, please?
Yeah. Would it be 50? 50
So
plus
X is
65?
50. And so does that satisfy, like it is isosceles, is it acute isosceles?
Um, yes,
It
it
is
would.
because all angles are less than 90.
Yeah, correct.
Now let's say the two base angles are 20 degrees and 20 degrees. What does that mean for the third angle?
It wouldn't be an acute uh
So
triangle.
what would the angle measure be?
It would be 140.
Very good. So now that's an obtuse.
Yeah,
Okay. So while this is possible, another type of question that you might see is like, is this sometimes, is more definition always or never true, right? So we've proven that it's sometimes true, but not always.
yeah, yep.
Okay. Let's look at another possibility here. Uh, is this possible or not possible? So I want you to kind of work through this a little bit on your own here. I mean, we've done a couple examples where you should be able to draw either one or the other and see if you can make it work.
Yeah.
Yep, a right triangle. A right angle is what?
90 degrees.
Okay, draw the 90. It's like 90 degrees.
I know,
It's
I know
aligned
what 90
perpendicular.
degrees is.
Okay, show me a right angle. Like that. Okay. Equilateral, look at the definition. All sides, all angles are congruent. So if you have three angles and one is 90, can the other two be 90?
Yeah.
The total angles always equal 180.
Yeah, I know.
So if one is 90, can the other two both be 90 also? No, they
No.
can't. They have to add up to 90.
Yeah, I know.
So then all of the sides and angles can't be the same because one is half of that 180. You know what I mean?
Yeah.
Does that sound right?
Yeah, I mean, I heard all the right words there. Usually these are graded with a, possible, not possible. So let's just say it's not possible.
Right.
That's it. That's be full credit. If it's possible, I'd like to see an example if it is. And that's kind of my style. So Remy sit and said, yeah, it's possible. I'd say, all right, well, what do we draw then to make this satisfy? And you're exactly right. If you start with a right triangle, doesn't matter what you draw, one angle is 90. There's no way to make the other angles 90. And if this is anything but 90, it's not a right triangle. So it is not possible.
Is Remy able to draw on the screen so that you're able to see it?
No.
He is
No.
not. It's yeah, so I sort of I this is I mean, it's one limitation of this format. I mean, full
That's
disclosure,
fine.
right? Like I can't see what he's doing. It
Right.
takes too long for us to go back and forth. So I sort of ask students, what are you drawing? Are you drawing this one or this one? And
Okay.
I try to limit that. In this class in particular, you do have that as an issue. So let's look at another possibility here. This is the next one is it is another right triangle. Is this possible? Possible or not possible?
No, it couldn't be possible.
All right, so what makes it not possible? What is the issue here with this one?
Well,
All right, let's
no
start.
side.
What's a scaling?
A scalion's a triangle that has no sides and no angles that are congruent.
Okay. So draw the right angle. And could you make all three angles different? Or are you locked in that they're all going to
They
be the
all
same?
have to be different.
Okay, so if you start with a right angle, because we know that, right? A right scaling.
Mm.
Let's do the information that you know, a right angle. Go ahead and draw it. Now, can you make every angle so that they're different?
Yeah.
Yeah. So it is possible. Is that right, Matthew? It is
This is
possible.
it is possible. What is the triangle that you've drawn? Give me the angle measures. I know that one of them is 90, but what is the other ones that you've got as an example here? Like what could the top angle be in your drawing or a drawing?
The top angle is just like, what is this? Like
It could
the
be
longest
it could be
one?
whatever you want. You already got a 90.
Yeah, I
He's
don't
asking
know.
you to create the next two angles.
Yeah,
Like,
what's an example of this angle? What could it be?
what do I say? Like a shorter one or
35 degrees.
yeah, like a 35 degrees and then 50
Okay.
degrees.
It couldn't be 50. They've got to add up to 180. So what would the other one be?
And one of them's already 90, so
Yes. They have to all three add up to 180.
um
Add
it's
90
gonna
and
take
35.
yeah, I gotta actually like do this. Like,
Write
I
it
can't
down.
just
Write it down. 90 plus 35. What does that equal?
it would be 55.
It would be 55. Good. All right. So just to address something your dad said there earlier, because it's important. Normally, like students supply problems or, like I don't really ask students to draw a lot. Like let's just say this was from his homework. Um, it would be like he would have this on his page already. I would just be grabbing a snip so that we're looking at the same thing. The drawing is challenging for most students. I mean, that's just a normal part of this course where you don't have the picture. So we've been doing a lot of problems, Remy, where I'm asking you to kind of decide, is it possible or not possible? Now let's go the other way. It's like, here's a triangle. Like, what words could you use to describe it? And we're going back to our original list. Is it equilateral? Is it isosceles? Is it scalene? Is it acute? Is it obtuse? Is it right? can you check the boxes on any of these on the right there from this? So basically, you got to look at this triangle, decide, okay, what do I know about the sides and the angles? What do I know about the angles relative to 90 degrees?
It would be a scalene triangle.
Okay, I agree. So we could check the box there. What else could it be?
Acute too.
It is acute, yeah. So you can see like acute scalene is possible.
Yeah.
So let's see if we can do another one. What we're doing right now is called classifying triangles. So you can go out to the internet and you can find a lot of worksheets on stuff like this. It's just called classifying triangles.
Yeah.
So here we go. We got another one here. What do you say? Can you check the boxes on any of these here for this triangle?
Yeah. Um, it would be a right triangle
Okay, so it's a right triangle. Anything else?
a isosceles triangle
Why is it isosceles?
because two angles are congruent.
And two sides are congruent. Good.
Yeah.
Excellent. Okay. Let's see if we can do one more here. All right. So as the grab these again. I create congruent check mark. Okay. All right. So let's see here. Find one more. All right. Here we go. All right.
Um, it would be a scalene triangle
Why is it scalene?
because no sides or no angles are the same or congruent. Or oh, sorry, my bad. I didn't see the 223s. It would be a isosceles triangle
Why is it isosceles?
because two sides and two angles are congruent.
So two angles are congruent, but they don't
That's two
tell you
sides.
the other side.
Yeah,
But you are correct in assuming, and this is the definition of isosceles, that if the angles are the same, the sides are the same. So yeah, it is isosceles.
yeah.
Anything else? Can you get anything from the right left here?
Would it be obtuse as well?
Yes. So to close that here, if you notice, we always checked one thing or another. We either check we check one of these and one of these, one of these and one of these, one of these and one of these. Now, not all combinations are possible, but you basically get one thing in each list. All right,
So
so
is that always the case that equal